just going to be building our skill with subtracting decimals. And this time we're going to take it one place value deeper. We're going to go to the thousandths position today, but absolutely same process, same procedure, same approach. Regroup where needed, align your decimal zones, simplify, okay? Page 187 is really straightforward because everything is structured for you, everything's aligned. Just go ahead and let's skip by 1, 2, and 3 for the time being. I'd like you to do 4, 9, 14. So in that order, just slide down the column, they increase in difficulty. 4, 9, and 14 on page 187. And I'm going to pull that up on my screen here.
Bless you.
Bless you.
Miss Moore, so just like 4, 9, and 7, or like 4 through 9 and 7?
No, just number 4, then number 9, and then right under it, 14.
Okay.
4, 9, 14, just those first 3. I'm going to pull them up here on the screen. Can you see them?
Yes.
Okay. So we're going to do this one, and this one, and this one. So regrouping where needed. I'm going to zoom in a little bit. Any regrouping involved here for number 4? Looks like number 4 has no regrouping at all. That's really nice. How about for number 9? Any regrouping? Looks like it. Right here, I don't have enough value in these digits, so I have to go get some value. I can go all the way down to the 6. Regroup it as a 5. We're going to regroup this as a 12. Then we're going to regroup this as a 9. And then we're going to change this guy to 11. How did we do with the regrouping part? Did we all have the same thing for the regrouping? Because if that part isn't quite right, then the rest of the problem won't be either. So we want to make sure the regrouping is all in agreement here. So this part, this column, the thousandths position, no regrouping needed. Let's just subtract. 11 minus 2, that's a 9. 9 minus 5, that's a 4. 12 minus 8, that's a 4. And 5 minus 4, it's 1. So in all, we should say the difference is, let's say it like a mathematician, 14 and 492 thousandths. Good job. We say the number in front of the decimal, then we say and, then we say the number behind the decimal and its position that it lands in. Good job. All right, number 14. It looks like some regrouping is needed again. So I'm going to go to a position that has more value than its minuend underneath it. So this is the spot. So instead of a 10, that's going to be a 9. Instead of a 13, that's going to be a 12. And this one will be an 11. Some people like to write it up above, which it's totally your preference if you like to write it, sink it down next to the digit, or if you want to put it up above. Now we can perform the subtraction. 11 minus 2, 9. 12 minus 4, 8. 9 minus 1, 8. 0, 1. So let's say it like a mathematician. 10 and 189,000. Okay. So tell me why the next column, numbers 5, 10, and 15, are a little bit more difficult. Tell me why.
Because there's no 0 for some of them.
Okay, so there's some empty positions, right? There's some empty spots. So how do we handle that?
By putting a 0 for each of those spots.
So Isabella, why would we put zeros in those spots? I saw your hand up too. Why would we put zeros?
Because we can't subtract, like, we can't just not subtract the 2 or subtract nothing from the 9.
Mhm.
Okay, I'm really bad at explaining things, but we need to do the complete subtraction.
You did. You're doing a great job. We can't complete the subtraction without the 0 there, right? We need the structure of the 0, even though it has no value, it has place value. It has position value. So it helps you perform the subtraction. So that was a great explanation. So last 3 we're doing on this page, go after 5, 10, and 15. Now that we have the placeholder zeros in position, now go ahead and do the subtraction. Wow, that was a lot of regrouping for number 10. Oops. Check them against mine as you finish. Now, if you see one of your digits is different than mine, first check that the regrouping number was correct. And if not, let me explain any questions you have about how I maybe got that particular number. Okay, because if the regrouping part doesn't make sense, then we need to look at that a little more closely. How did we do with these? Number 5, piece of cake. Number 10 was very complex with all of the regrouping in 2 different spots, 2 different zones. Same with 15. Yes, Isabella, question?
I didn't really have any digits different than yours for number 15, except I dropped down the 0 for the one begin.
So you just did this.
Yeah.
Now, zeros before a number in the positive direction don't carry any value, and zeros behind a number after the decimal don't carry any value either. So we can add or remove as many of those zeros as we'd like to show just the structure of your answer, but we know they don't carry any value.
So still correct?
Yeah, it's still correct. Now notice for number 4 and 5, we'd still put a 0 in the ones position, even though it doesn't carry any value, because it holds a good structure for our number. Because when we say the value of that number, we say 0 and 119 thousandths. You could just say 119 thousandths, but the 0 gives us a little bit better of a picture of where is the 119 landing in the place value system, okay? All right, we're gonna peek. Remember yesterday I sort of coached you through the homework? We're gonna coach and guided practice as we preview the homework. So what I'd like you to do is show restraint. Don't try and go ahead and quickly get it done. Let me teach while we preview it. And I'm going to kind of grab one from each of the sections and give you reminders, give you tips, give you strategies to approach these, because these are far more complex than the ones here, right? These were already set up for you. They're already aligned for you. They were easy to find the difference. But now we're taking it to the next level and saying, okay, now use the skills you are aware of now with subtracting decimals. Now apply it to other domains like order of operations or fact families or problem solving. So we're going to use that information in a more complex way here on your homework, okay? So for sections, our numbers 1, 2, 3, and 4, you can see it's multi-step, right? There's a couple things going on. And when you have multi-step expressions like that, what should be lighting up in your brain is this memory or recall of order of operations. So in this kind of area next to the instructions, maybe write a note for yourself, use order of operations. You can just put OOO. What are the order of operations? Do you remember? Yeah, let's say them together. Ready? Parentheses, please, excuse.
Division, multiply, then division, addition, and then subtract.
Right. Please excuse my dear Aunt Sally. You know that quick little, what's that called when you have a little related catchphrase to help you remember something? Oh, I can't think of the term. Anyway, it's this shortcut that your brain does to remember a certain content, right? And so we say, please excuse my dear Aunt Sally, to remember the order of operations, which are parentheses, have to come first. Then any exponent values, remember those itty bitty tiny numbers that represent repeated multiplication is happening. Then multiplication and division are handled at the same step, whichever one happens first, from left to right through the expression. And then finally, addition, subtraction, whichever one happens first from left to right through the expression. So in number 1, for instance, do we see any parentheses situations that are there? Absolutely, right? Do you remember how we handled order of operations, simplifying problems? How do we show what part we were working on? How do we call attention to what part we were working on? Do you remember? We underlined it. So we're just going to underline the part that we're focusing on now. Okay, that's it. That's the only part we need to look at right now. And I can't calculate that in my head accurately. I want to make sure I do it right. So I'm going to pull that problem off to the side. And then when I get the answer, I'm going to dump it right underneath this line to show I'm replacing this expression piece with a simplified version of it, an equal value of it. So let me take this part off to the side, maybe up here, and we'll align the decimals. We will perform the subtraction. You might need a separate sheet of paper, it looks like, with all of this extra calculations going on here today. But I'm aligning the decimals, so I'm using my subtraction skills here. And we're going to regroup where needed. Let's see, I can't do the 7 minus 9, so I have to get some value from this 5 here. This changes to 17. I'm not going to be able to do this subtraction either, so let me get some value from the 1's position. Everyone writing this down? Let me know if I'm going too fast, okay? I can't see where you're at in your problem. We have this problem set up and regrouped, ready to roll now? Okay, let's do the subtraction. 17 minus 9 is 8.
8.
And there's 4, and there's 5, and there's 1. So this value, 1.548, is not the answer, but it represents this piece of the expression. So we're going to go and put it right underneath the place it's the spot it's replacing it in the total expression. We're trying to wean it down into one value. Remember, it kind of looked like an upside down triangle the more we simplified. So what part has not been handled yet? What part needs to be dropped down and dealt with?
The 4.
Minus 4.
Minus. So that's another reason why I like the underlining, because it calls attention not only to what am I working on right now, but what haven't I even dealt with yet? Drop it down. And you keep going until everything's been underlined, everything's been handled. And it's just a good way to stay organized when you're working with a complex equation. So, hey, this is the only thing left to do. I'm gonna underline that part. That's what I'm working on next. And then I have to pull off to the side because I don't have any space to perform this calculation right here. I'm just going to put the simplified version, the answer to it. I'm a little confused now. How do I set up 4 minus 1.548? Because there's no decimal point to guide. Where do I place that 4? How do I know where to put it in relation to the other number? Where do I put the 4? What place value is the 4 in right now?
The ones.
In the ones position. And I know that because it's a 1-digit number and there's no other digits around it to give me more information. So that 4 is sitting in the ones position. So when I stack those decimal zones, I have to make sure to put the 4 in the ones position. If it's in the ones position, the decimal point exists right next to it, right? Okay, I can't do this subtraction, right? Without adding what?
Placeholder 0.
0.
Placeholder zeros. Load it up. Now I can perform the subtraction. I have to regroup, but that's okay. I can perform the subtraction. This would change to a 9, this would change to a 9, and this would change to a 10. All right, now that I have it structured, it's regrouped, now we can just go through with the calculation. 10 minus 8 is 2, 5 minus 4 is 5, 9 minus 5 is 4, 3 minus 1 is 2. So this number actually represents the entire answer to this expression. They are equal in value, aren't they? Because they replaced each other little by little. I was trying to find the simplest version of this expression. So you know how when someone's going on and on and on telling you a story and you're like, get to the point, what happened, right? So it's kind of like an expression is really complicated. You can't really tell its value. Get to the point. What is it worth? So that's what you do when you perform order of operations. You slim it down to one value, one term.
Miss Moore.
Yeah.
Are you gonna do like one problem of like from like each section?
Yeah. So
Okay.
previewing for yourself, number 2, what part would you underline first? I'm not going to do number 2 with you, but what part would you underline first if you were going to go solve that one next? What part would you underline? What part would you handle first? Check your order of operations list to help you.
The parentheses?
Yeah, so we're going to underline that part. Maybe if you want to underline it right now on your paper, that way you know what to do first when you go to work. How about number 3? What would we do first? Does it matter which one we do first?
No.
Could we solve them both separately and then drop it down and find the difference between the two? Yeah. You could set up 2 little problems and then find the simplified version of them both, replace the values, drop it down and keep going, simplify again. How about number 4? Definitely the parentheses part, right? All right, cool. Now, for the next band of problems, 5 through 9, I'm going to lean on a strategy that I hope you're starting to use when things get tough is try to relate it to something you've already mastered. Try to relate it to something that you're comfortable with. And so when I was looking at these complicated problems, I was thinking to myself, well, how does that look like something I've already handled before? I'm going to erase all this stuff up here so I have a little more space to write and can talk to you a little bit more focused. What I thought about when I saw this problem is I saw a problem like that before when I was little. My teacher would do these mystery boxes, and then she would say -2 is equal to 9. And then we would have to figure out this mystery spot, right? So if I can do that problem, then I can do this problem by using the same approach, right? How do I find the answer to the mystery spot in my simple problem that I wrote here in green? How do I find the answer to that?
Add the 9 and the 2.
So you're using this knowledge that they're related to this number in a unique way, right? And that's your fact families coming into play, right? So the 2 and the 9 have to come together to make this larger number that represents their total value, right? And that's fact families. Can you use fact families with decimal numbers? Sure. Or at least the idea of them, because these two numbers are related exactly to each other in only one other way, only one other number. So even though you have a little bit more complex of a number, these two numbers still belong in these two corners. So what would you do to find the missing part?
Add them together.
Add them, just like you did for the simpler problem, just the same approach, right? So for number 5, you were maybe write a little note to yourself, add. And draw maybe a fact triangle to help you remember why that it is that you add. Now, I'm going to rearrange my problem here because the mystery spot's in a different location for number 6. So let me just, I'm not going to erase this. I'll just erase this part here. This time I know the 11 part, but I didn't know the 2 part. So how do those two relate to each other? So if I wanted to find the 2, what did I have to do between the 11 and the 9 this time?
Subtract it. 9.
Yeah, so in order to find this mystery spot, I would have to do the same approach, right? So I'm relating something I know I can master and handle to something more intricate. So what do you think about number 7? Would I have to add or subtract those values?
Add.
Add, subtract.
So I'm going to have to add them because the missing part is the biggest number. And the biggest number is always achieved through the adding of the smaller 2 terms. So I would have to add the smaller 2 terms to make the biggest one, which would always be in the top position for a subtraction problem. For an addition problem, where is the biggest term always located? On the top or on the bottom? Where's the biggest term always located in an addition problem? What do you think?
On the top.
For an addition problem. So here, I'll draw one out. Where's the biggest number? It's always located at the bottom of the stack, but yes, it's still located at the top of the fact triangle, right? So we can use these tools to help us figure out a path to solving harder problems. Number 8, how would I find the missing part? Would I add or subtract?
Subtract.
All right, give yourself a little note. How about number 9? What would I do?
Subtract.
Subtract.
Okay. So do you feel confident that you can handle 5 through 9 now? You're going to probably have to draw them on a separate paper off to the side because there isn't enough space here in your workbook. I mean, you'd think a workbook would let you have space to work, but they like to smash in as many problems as they can, I think, to make it cut down on their printing costs, I bet. But all right, we're good with this. Last part that is a little interesting because some people, they've never even noticed this before on at the gas station. So you might have noticed the price and that there's 3 different types of gasoline available. But have you ever noticed this part at the back before? Represents an extra fraction of a cent that you're paying for 1 gallon of gas. So 1 gallon of gas does not cost, for instance, $2.35. It costs $2.35 and 9/10 of a thousandth of a cent more. So you might think that that's much more money, but when you go to the gas station and you buy 10 gallons of gas, that definitely increases your total cost, right? And if everyone is paying an extra 9/1000ths of a cent for 1 gallon of gas, times all of the people that visit the gas station that day, times all of the people that visit the gas station that year, right? It adds up. So gas stations figured out a way to make you think that you're saving, you're getting a good price, but they add an extra fraction of money onto the cost to make your overall kind of cost increase for them. So when we look at this sign, they're asking us first to describe kind of what these things represent. What do they mean when you see it? What kind of message is it sending you? So tell me, just by looking at the sign, what is the cost of a gallon of regular gasoline? You would say about $2.35, right? How much is the cost of the plus? About $2.49. How much is a gallon of the Supreme gas? $2.59, right? So in number 10, when they ask you, what does the expression represent? The word represent means describe with words what information is that expression showing. So what is this showing? It's showing a difference. There's a subtraction sign there. It's showing the difference between what? Which 2 gasoline types is it showing the difference between? Can you look at the sign and see which type of gas costs that much and which type of gas costs this much? What is it describing the difference in? The difference between what?
Supreme and regular.
Right, so in our answer, we would write the expression shows, has Mrs. Moore, the other one, talked to you about turning the question into your answer. Okay, so the question says, what does the expression represent? So I'm going to tell you, the expression represents, or the expression shows, the difference between 1 gallon of Supreme gas and 1 gallon of regular gas. Would you agree with that? I'm hoping I can make it a little bigger here. There we go. The expression shows the difference between 1 gallon of Supreme gas and 1 gallon of regular gas. Okay, so we've handled the first part of the question. When you're ready to go on to the second part, let's try to figure out what the meaning of that sentence is there, okay? Tegan, how you doing with this stuff? Tegan, where are you? Oh, there you are. How you doing, honey?
I can't hear Tegan.
But are you doing okay, Tegan? Okay. I just haven't heard from you much, so I'm hoping you're okay. John, you all right? All right, so then the next part of our question, and I kind of like to highlight as I go because oops, I don't want it in blue. I don't want it in yellow. The next part of the question says to use the value of the difference in your answer. What's the word difference mean? The difference means the answer to the question, right? What is the answer of the difference here? What is the actual value between those two? Do we know, or do we have to stack it up and solve it? Let's stack it up.
Stack.
We do the subtraction, regroup where needed. Yay, we didn't need to do any regrouping. So now we can go describe the answer with words. The difference is 0 and 24. We can cut this 0 off the back. It carries no value. 24 cents, essentially. The difference is 24 cents, since we're talking about money here. Okay, we'll just add that in the back here. The difference is 24 cents. Now sneak a dollar sign in there. So it looks like 24 cents. Good. So using some of the information we talked about, I think you can handle the next two. And I really like 13. I really like doing problems that involve you finding the mistake. So the more you look for errors, the more you're going to be able to do that with your own work and be able to recognize mistakes and avoid them. So I do want you to perform the rest of this entire page, okay? All right, boys and girls, tomorrow we don't have a Zoom, but it's the same types of material involving subtraction of decimals and aligning different quantities. I've been looking at the pages just to preview them, and they are easier than the past 2 days have been. They only involve 2 place values really to the 100th position, but I think you should have a good time with it. I think it should be straightforward. And then I'll see you again later in the week for a Zoom, okay? Have a great rest of your day, all right, everyone? Before I go, any other questions for me? Okay.
Bye, Mrs. Moore.
Bye, honey. Bye, see ya.
Have a great day.
Bye. Have a great day.